Every groundbreaking invention has a story. The story of quantum computing involves brilliant scientists, heated arguments, and ideas so bizarre that even Einstein refused to accept them. Let's discover how it all started. Our journey begins in 1900. A German scientist named Max Planck is studying why hot objects glow different colors. He discovers something unexpected. Energy doesn't flow smoothly. Instead, it comes in tiny packets, like individual Lego blocks. He calls these packets quanta. Think of it this way. What if you could only pour water one spoonful at a time, never any amount in between? That's actually how energy behaves at the smallest scales. Over the next 25 years, brilliant scientists expand on this discovery. Einstein explains how light works. Bohr figures out the structure of atoms. Heisenberg discovers that measuring one property of a particle affects other properties. And Schrödinger writes an equation that describes the quantum world. This equation shows how quantum particles change over time. You don't need to understand the math here. Just know that it's basically the rule book for how tiny particles behave. But here's the twist. Einstein strongly disagreed with these quantum ideas. He spent years trying to prove them wrong. Spoiler, Einstein was wrong, and quantum mechanics was real. Now let's jump to the 1950s through the 1970s. Computers are being invented, but they're enormous machines that fill entire rooms. Each year, they become smaller and more powerful. Scientists start tackling increasingly complex problems. Then, in 1981, a physicist named Richard Feynman runs into a serious problem. He's trying to use computers to simulate how atoms behave. Simulating one atom, no problem. 2 atoms, still manageable. 3 atoms, getting difficult. 10 atoms, the computer can barely handle it. Then Feynman realizes something important. Atoms naturally follow quantum rules. They exist in superposition and can become entangled. Trying to simulate quantum behavior on a regular computer is like trying to describe the ocean using only words, when you could just show someone actual water. And then comes his breakthrough idea. What if we built computers that actually use quantum mechanics? A quantum computer simulating quantum physics would be natural, like water describing water. In 1985, a British physicist named David Deutsch turns Feynman's wild idea into something concrete. He doesn't just say quantum computers could work. He designs exactly how they would work. He invents quantum logic gates and quantum circuits, creating the entire theoretical foundation. He even creates the first quantum algorithm, similar to what we covered in video 4. And he proves mathematically that quantum computers can solve certain problems that regular computers simply cannot. The theoretical groundwork is complete. Quantum computers are possible, but everything is still just equations on paper. Then, in 1994, a mathematician named Peter Shor shakes up the entire field. He discovers an algorithm that could crack the encryption protecting the internet, the codes that keep credit cards safe, emails private, and government secrets secure. On a regular computer, Breaking these encryption codes would take thousands of years. On a quantum computer using Shor's algorithm, just hours. Suddenly, governments, militaries, and technology companies take notice. This isn't just fascinating science anymore. This has real-world consequences. The race to build quantum computers officially begins. Here's how the progress unfolded. Yes, 15. 3 times 5. Not exactly cracking military codes. But it proved the concept actually works. Their quantum computer solved a specific problem in 200 seconds that would take the world's fastest supercomputer 10,000 years. Today, you can actually program real quantum computers from your own laptop through cloud services. From Max Planck's strange discovery about glowing objects in 1900 to Feynman's revolutionary idea to the powerful machines we're building today, it's been quite a journey. It took over 100 years of brilliant minds asking, "What if?" and refusing to give up. Now we're building machines that harness some of the strangest rules in the universe. And you know what? This is just the beginning. This is The Knowing Lens. This was the final documentary of our quantum series. And if you thought this was wild, you need to see how we got here. Check out the rest of the quantum series and drop a comment about which topic we should tackle next.